Hello everyone and welcome to this video where we are discussing the Maxwell distribution of speeds and the mean free path. Now in general we know that according to the kinetic theory of gases, molecules have a random distribution of speeds. All of them are moving in different directions. Now some of these molecules may be moving really slowly while others may be moving really fast. It is also possible that for a molecule moving in a particular direction, there is a molecule moving in the exact opposite direction. When we actually plot the distribution of these speeds on a graph, we obtain what is known as the Maxwell-Boltzmann distribution. The Maxwell-Boltzmann distribution is nothing but a graph which is telling us how many number of molecules are available within a particular range of velocities. To understand this distribution of speeds, there are three main different types of speeds that we must study. The first one is what corresponds to the peak of the graph. This is the most probable speed, given by the formula root 2 kBt by m, where kb is the Boltzmann constant, T is the absolute temperature, and small m is the molecular mass. The most probable speed corresponds to the largest number of molecules having this particular speed, and therefore its name, most probable. The next one is very self-intuitive. The next type of speed is the average speed. Now the average speed is nothing but the average of the different speeds of the gas, and is given by the formula root 8 kBt by pi m. But as we have already seen, it is quite possible that when one molecule has a particular speed, another could have an exact opposite speed, and in such a case the average could turn out to be 0, and looking at the average will give us no information about the distribution. To remove this difficulty in our observation, we also have the third type of speed that we study, that is the root mean square speed. We already know by now what it means to have a root mean square speed. The formula for this speed in the Maxwell distribution is given by root 3 kBt by m. The comparison of these three speeds is very simple. The one to the most right of the graph will be the highest, and as such this means that the root mean square velocity is higher in value than the average speed, which in turn is higher than the most probable speed. The Maxwell-Boltzmann distribution depends upon temperature, and this graph that we have plotted is plotted for a fixed temperature. When you try to plot the same distribution for the same gas at a higher temperature, you will see that the graph not only moves to the right but is also flattened in comparison. It moves to the right because now the molecules will have a higher velocity because of the higher temperature, and therefore it moves to the right, which includes higher velocities on the graph. The flattening down tells us that now the value of the most probable speed has gone down. From the idea of the random distribution of velocities, the next inevitable concept is the idea of collisions between molecules. And from this springs the idea of the mean free path. When molecules collide, they transfer energy and momentum between them. The average distance that a molecule travels between its one collision and the other is what we call as the mean free path, denoted by the Greek letter lambda. If we carefully study the motion of a molecule within a gas, we will see that a molecule collides with only those other molecules that lie within some range. And this range is nothing but the diameter of the molecule itself. So this molecule ends up colliding with only those other molecules whose centers lie within a range of the diameter of this molecule, and this we will denote by d. And thus comes the idea of the mean free path, which is crucial to the study of the kinetic theory of gases.